In this section we want to look at some quadratic inequalities, and here's our first example. We have x squared plus x minus 6 is greater than 0, so it's a quadratic inequality. I'll begin by factoring. I'll factor this trinomial into the product of two binomials. First terms will be x, so that x times x is x squared. Last terms have to multiply to give me 6, so how about 3 and 2? Inside I have 3x, outside I have 2x, they differ by x, so let's make that positive and that negative. Now what I want to do here is I want to take and make a sign chart for these factors. I just want to know where the factors are positive and where they're negative. Once I know that, then I'll be able to tell where their product is positive and negative. So I'm going to start with my factor x plus 3, and I'm going to say, where is x plus 3 0? Because 0 is the dividing line between positive numbers and negative numbers. Well, x plus 3 will be 0 when x is negative 3. So I'm just going to say, here's negative 3. That's where x plus 3 is 0. For numbers down below this, like for instance negative 10, negative 10 plus 3 is negative 7. I have negative numbers. Up above that, I have positive numbers. Next, I'm going to look at my factor x minus 2, and I'm going to do the same thing. Where is x minus 2 0? Well, x minus 2 is 0 when x is equal to 2. Let's put that up here. For all numbers below 2, x minus 2 is going to be negative. For instance, 0 minus 2 is negative 2. Negative 3 minus 2 is negative 5. So for all the numbers down here, when I substitute them into this factor, I end up with a negative number. So negative down there, positive up there. So now I ask myself, how about the product of x plus 3 and x minus 2? Because that's what I'm looking at right here, is the product of x plus 3 and x minus 2, and I want that product to be greater than 0 or positive. Well, I know that x plus 3 is negative in this region, and x minus 2 is negative in this region, so their product must be a negative times a negative, which would be positive. In this region right here, the one factor is positive, the other is negative, so their product must be negative. And in this region, both factors are positive, so their product must be positive. So since I want the product of these two factors to be positive, I know I'm talking about all the numbers down here together with all the numbers up here. Any number that appears in one of these two regions is going to give me a positive product for x plus 3 and x minus 2. The last thing I want to do is check my endpoints. I see that this is a strictly greater than inequality, so my endpoints will not be included in the solution set. So here's a graph of all the real numbers such that they make the product of x plus 3 with x minus 2 positive. These are also all the real numbers that are solutions to this quadratic inequality. So how do I solve these? I write it in standard form. If it's not in standard form, factor it, make a sign chart for the factors, and then reason out, depending on the signs of the factors, where my product is positive or negative. Let's look at another example. Another quadratic inequality, 6x squared less than 5x minus 1. Let's put this in standard form by writing this as 6x squared minus 5x plus 1 is less than 0. So I'll add negative 5x to both sides. I'll add positive 1 to both sides, so I have it in standard form with 0 on this side. Now let's factor. If this factors, it'll factor into the product of two binomials. I need a 3x and a 2x possibly to multiply and give me 6x squared. The last term's 1, so that's pretty easy, 1 and 1. Inside is 2x, outside is 3x. I add them together and get 5x, so I'll make those two negative. Now what I want to do is I want to take my two factors right here and draw and make a sign chart for each one of them. So I'm going to start with 3x minus 2 and see what the sign of that factor is. So for 3x, I said 3x minus 2, I mean 3x minus 1. Okay, this factor will be 0 when 3x minus 1 is 0, which is when x is 1/3. Now this one's going to be 0 when x is 1/2, so 1/3 is less than 1/2. Let's put it over here. So I'm going to say 1/3. This factor will be negative for all the numbers to the left of 1/3, and it will be positive for all the numbers to the right of 1/3. Now take my next factor, 2x minus 1. Let's see if that went off the screen. No. Okay. So 2x minus 1 is 0 when x is equal to 1/2. Let's put that right here. When, for numbers less than 1/2, 2x minus 1 will be negative. And for numbers greater than 1/2, 2x minus 1 will be positive. So here I have the signs, positive and negative signs, of my two factors all along the real number line. I look back to my original equation here, or inequality, and I see I want the product of these two factors to be less than 0. So I want this product to be negative. I'll look in my regions. There the product is positive. Here in this region, the product is going to be a positive number times a negative number, which is negative. And in this region, the product of two positive numbers will be positive. So I'm looking for this region right here. I want to write this as an inequality. Whoops. That's positive 1/3, positive 1/2. I want all the numbers in between there. And then I'll look back to my original inequality, strictly less than. So I'm going to use my open parentheses here. And there is the solution set for this original quadratic inequality. All the numbers in here on the number line are numbers that make this original inequality a true statement. Let's look at another example. Here I have x squared minus 9 is less than 0, so I'll start by factoring this. That's an easy one. X plus 3, x minus 3, less than 0. Okay, I want to look at a sign chart for my factor, so I'll look at the factor x plus 3. I'll draw a little number line here, and I'll say, well, x plus 3 is going to be 0 at negative 3. It'll be negative down below that and positive up above that. Then I want to look at my factor x minus 3, and it will be, let's see, 0 when x is equal to 3. It'll be negative down below that and positive up above that. So here I'm looking for numbers on the number line for which the product of this factor with this factor is less than 0. So I want my product to be a negative number. I look in here and see here's where one factor is positive, the other one is negative. So in here I have a negative product. So I'll finish this up by drawing a number line. I'll put in my endpoints negative 3, positive 3. I want all the numbers in between here. And then I look back and see that's strictly less than, so I'm going to use my parentheses again. If it was less than or equal to, I would use brackets, but it's not, so I use parentheses. And there's all the numbers on the real number line that satisfy this original quadratic inequality. Here's one more example. This last one, I have the product of these three factors greater than 0. So it's already in factored form, so I'm going to look at the sign chart for each of the three factors. So for x minus 2, let's see, I know that x minus 2 will be 0 when x is 2. Let's just check this. This is going to be 3 and this is going to be 4. So let's just put x equal 2 right here. This factor will be negative for numbers less than 2, and that factor will be positive for numbers greater than 2. When I look at my factor x minus 3, I know it will be 0 when x is equal to 3. So let's put that in here. It will be negative for numbers less than that and positive for numbers greater than that. And then my last factor here, x minus 4, it will be 0 when x is equal to 4. It will be negative for all the numbers below 4 and positive for all the numbers up above 4. So how about my product of all three of these factors? Well, let's see. A negative times a negative times a negative will be negative. A positive times a negative times a negative will be positive. A positive times a positive times a negative will be negative. And a positive times a positive times a positive will be positive. So I want the product of these three factors to be greater than 0. I want it to be positive, so I'm going to look in here and then also out here for my solution set. So let's see, how about I'll go from 2 up to 3, not including 2 and not including 3, and then I'll go from 4 on up. So how does that look? all the real numbers between 2 and 3 or above 4 are numbers that satisfy this original inequality. So this is one way to do these inequalities with this sign chart. I like it. After you get used to it, it's pretty simple, and you always come up with the right solution right here. And that's a look at graphing some inequalities, some of which are quadratic and some are actually a little higher degree.